Hello friends, I welcome you all to this class. This is mathematics class, and today we are here to look at this important topic, relative minimum and the maximum value of a given function. So this is actually under the application of derivative, and we have looked at this topic in our previous class, and we are here to solve another example on this topic. And I told you that we are going to make use of these two things I wrote down on the board here, that at the at the minimum point, the second derivative of the function with respect to the independent variable will be what? Positive, greater than 0. And at the maximum point, the second derivative of the function with respect to the independent variable will be less than what? 0. That's negative. These are the two second derivative tests for minimum and the maximum point. So in this question, they ask us to find the relative maximum of the function. Relative maximum of the function is the same thing as relative maximum value of the function. They may ask you to find the local maximum, local minimum. Local maximum is the same thing as relative maximum. Local minimum is the same thing as relative minimum. So they ask us to find the relative maximum of the function. So that means the relative maximum value of the function, or the local maximum value of the function. What I wrote down on the board just now is that at the critical point, the first derivative of the function with respect to x is equal to 0. So the first thing you have to do is to first of all find the critical points. I've done a video on how to find the critical points. Just if you take the first derivative of the function with respect to the independent variable, equate to 0 and solve. So let's differentiate the function. If you differentiate 3x squared with respect to x, what's the power? 2. 2 multiplied 3, you have 6. And if you remove 1 from 2, you are going to have 1. So that's 6x power 1. Then differentiate x raised to power 3. If you bring down this power 3, you are going to have minus 3x. If you minus 1 from 3, you are going to have what? 2. And at the critical point, this first derivative should be equated to what? 0 at the critical point, equal to 0. So let's first of all divide both sides by 3. If you divide 6x by 3, you are going to have what? 2x. If you divide 6x by 3, you get 2x. If you divide the negative 3x squared by 3, you are going to have negative x squared. Then equated to 0. If you divide 0 by 3, you are going to get 0. I've divided both sides by what? 3. Because 3 can divide them, right? So another thing we notice here is that what? X is common. We can factorize x. So this implies, since x is common, I can factorize x. That's x open bracket. Then if I factorize x, x divide 2x, I have 2. Minus x divide x squared, I have what? X. Equated to what? 0. So the product of these two things are giving us 0. This implies that x is 0, or 2 minus x is 0. Because the product of these two things are giving us 0. So one of them must be what? 0. So this implies that x is 0, or if you move negative x to the other side, you will have that x will be equal to what? Positive 2. So x is positive 2, x is 0 or positive 2. These are the critical points. Let me just write it down for me. Remember when we were finding the critical points, we differentiated the function with respect to x, and this, I have written it down. This was what we got: 6x minus 3x squared. If you want to check it, you can differentiate this function and check. So if you differentiate this function, you are going to get this. So if you differentiate this first derivative again, you are going to get what? The second derivative. So to find the second derivative of the function with respect to x, that's what we are looking for. So we differentiate this again. Differentiate 6x with respect to x, we get 6. Differentiate this negative 3x squared with respect to x. What's the index? 2. 2 multiplied negative 3 is negative 6. Then if you remove 1 from 2, you are going to have what? 1. So negative 6x power 1. So this is what we got, right? What's the next thing? You test the point, right? So we have 0 and what? 2. So of course, if you put x for 0 here, this 10 will become what? 0. Remaining 6. You are going to get something greater than what? 0, because 6 is greater than 0. So this will give us minimum, but we are not looking for minimum, we are looking for relative maximum. So we are going to use what? 2. So second derivative of the function with respect to x, when x is what? 2. This is the one we are checking, when x is 2. So this is equal to 6 minus 6 multiply 2. So put x for 2 here. That is 6 minus 6 multiply 2 is 12. And this gives us what? Negative 6 less than what? 0. So the second derivative test at x equals 2 at the critical point 2 gave us what? Something less than 0. So x equals 2 will give us what? The relative maximum value of this function. So I'm going to substitute what? X for 2 in this given function, because the critical point will give us the relative maximum value, because we got second derivative test of it gave us something less than 0, which is in accordance with what? The relative maximum. So you are going to have that y will be equals to, we are putting x for what? 2. So this will be 3 into 2 raised to power 2, right? Minus 2 raised to power 3. I substituted x for what? 2 here. So this will be equal to 3 into 2 raised to power 2 is what? 4. Minus 2 raised to power 3 is what? 8. So this will be 12 minus 8, which is what? 4. Right? Because 2 raised to power 2 is 4. 4 multiplied 3 is what? 12. 2 raised to power 3 is what? 8. So 12 minus 8 will give us what? Positive 4. So positive 4 is the relative maximum of this function, or you say relative maximum value of the function, which is also called what? The local maximum. So thank you so much for being part of this class. I'm expecting in our upcoming class as we treat the absolute minimum and absolute maximum value of a given function. Thank you. So I've written it down here that the critical points are what? 0 and 2. These are the critical points we got.